Hello, Math 2 students. It's Mrs. Robinson. I'm back to work the Practice Benchmark Chapter 8 with you, and it's your last benchmark of the semester, so let's go through it real quick. All right, we're going to find the measure of arc BDA. Here's B, here's D, here's A. So that's going to be a major arc, BDA, all the way around. So we know all the way around a circle is 360 degrees, and the little piece left is 40, so we're just going to subtract that off, and we're going to get 320 degrees. Bam, that's the measure of arc BDA. You're done. Next, you need to find the measure of YZW. Here's Y, here's Z, here's W, and it's an arc. So we're going to find the measure of this arc. We can see the central angle, the measure of the central angle, the measure of the central angle is the same as the measure of its arc. So if this is 103, this is also 103. If this is 90, this is also 90. So we just need to add these together. 103 plus 90 is going to be 193, and you're finished. All right, this one wants to know the area of the circle. Leave your answer in terms of pi. Pay attention to this, please, how it asks you to leave your answer. So to find the area of a circle, we should know that area is pi times the radius squared. It gives us the diameter, so we need to find the radius, half of the diameter. So we're just going to go 3.6 and divide it by 2, and that will give us the radius. If I divide this by 2, I'm going to get 1.8. That's my radius. So my area is just going to be pi times 1.8 squared. And if I square 1.8, I'm going to get area is pi times 1.8 is 3.24. And I'm going to multiply that by pi. I like to put pi at the end, and you're finished. All right, find the area of the shaded region in the figure to the nearest tenth. Now, instead of finding the whole area, I just want this shaded sector. I know I can find the area of the whole circle by doing pi r squared. So I zoomed it in. I didn't know I could do that. Oh, and it's back out. Okay, so to find the area of the shaded region, I'm going to do the area of the sector. So it's basically finding a percentage of it. I want to do 60 degrees is the measure of that angle and also the measure of this arc. It's 60 out of the total circle, which is 360. So I'm finding a percentage of it. 60 out of 360 times my area of pi times my radius squared. Well, I know my radius is 5. They gave me that. So I'm just going to go 60 divided by 360 times pi times 5 squared. Now it asks me to the nearest tenth. I don't leave my answer in terms of pi. I can just do this on the calculator. 5 times 5 times 60 and divide that by 360. And then I'm going to multiply that amount times pi. And I'm going to round to the nearest tenth. So I'm going to do the squigglies for it's approximately. It's 13.089. So I'm going to go 13 and I'm going to round up to 13.1. And that will be my final answer. All right, let's push pause. All right, this one asked me to find the area of the sector AOB. So I want to find the area, it says the area of sector AOB is 225 pi feet squared. Now it wants me to find the area of the shaded region. I could easily find the area of this sector. It's given to me, but I could find it by doing 90 divided by 360 times pi r squared. They already tell me the area of the sector. Sector area is 225 pi feet squared. I need to just find this piece, not the whole sector. That's the area of the whole sector. I need to find this piece, so I need to subtract off the area of the triangle area. So I have the sector area. If I subtract off this triangle area, that will give me this little piece. So the triangle area I know is 1/2 times the base times the height. Now the nice thing, this is a right angle. If this weren't a right angle, to find the triangle area, I would have to drop in altitude And then I could do a special right triangle given one piece to figure this out. But because it's a right angle, I have the base and the height. This is a radius, so it's also 30. So I'm going to go 1/2 times 30 times 30. 30 times 30 times 1/2 is going to give me 450. So I'm going to do the sector area minus the triangle area. Now it said to find the exact area of the shaded region. So that means I'm not going to round using pi. I have to leave it in terms of pi. Okay, so my answer would be 225 pi minus 450. And that whole thing is actually feet squared. And that's how your answer would look. All right, number 6, assume that the lines that appear to be tangent are tangent. So this appears to be tangent to this circle, and O is the center of the circle. Find the value of x. All right, looking at this one, it tests to see if I know the properties of a tangent. A tangent to a circle at the point of tangency is going to meet at 90 degrees. All right, so this should be 90 degrees right here. And it's not letting me draw. Let's try that again. This should be 90 degrees right here. Okay, so I can easily find the value of x because it gave me this was 51. 90 plus 51, and then I'm going to subtract that from 180. And I'm going to get 39. So x is 39 degrees and you're finished. Okay, this one is a little trickier. Here, once again, you have a tangent. The radius to the tangent line at the circle is 90 degrees. So you have a right triangle. We're going to go ahead and set up a Pythagorean theorem. So we have our hypotenuse right here. And because we have two x's, they're both the radius, this is a little trickier. We're going to set this one up. Hold on one second. Okay, I'm trying to get this pen to work. Come on, pen. All right, so we're going to go ahead and set this up. We have our a squared, so one side squared plus the other side squared plus b squared is going to equal c squared, or hypotenuse squared, which will be x plus 6 squared. All right, now working this out, we're going to have to FOIL this out, which is kind of a pain. So to multiply this out, we're going to have to do x plus 6 times x plus 6 and FOIL this out. So the first terms are going to give us x squared. Then the outer terms are going to give us 6x. The inner terms, once again, 6x. And then the last terms plus 36. So this all ends up being x squared and then two 6x's. These are like terms, so that becomes 12x plus 36. And that's going to equal x squared plus 9 squared is 81. All right, now we're going to go ahead and simplify this and solve for x. Great thing about this is when I subtract x squared from both sides, they fall out, and I don't have to deal with x squared anymore. Now I'm going to solve for 12x. I'm going to solve for x. So I'm going to subtract off 36 to this side so that I isolate and get the x by itself over here. Subtract 36 to this side, so I'm going to do 81 minus 36 and get 45, and that's going to equal 12x. And then to solve for x, I just divide by 12 on both sides. And my solution is going to be 45 divided by 12. And I'll go ahead and leave this in decimal form, 3.75. And that is my solution for this problem, not number 8, of course. All right, so that's how you solve for x. That one was a little trickier because we had the foiling, but the basic concept is just, it is Pythagorean theorem. Okay, here's another similar problem. AB is tangent to circle O at B. Find the length of the radius R. So this time we're going to find the radius. They tell us AB is 6, so always write it out. AO is 8.3. This is 8.3. We're going to round to the nearest tenth, so pay attention to that. We're looking for R. So we know since it's tangent to the circle, at the radius, at the point of tangency, you have a right angle. So once again, Pythagorean theorem. So we're going to go 6 squared, so that's our a squared, plus b squared, r squared, equals c squared, our hypotenuse, which will be 8.3 squared. Now we're just going to work this out and solve for r. So 6 squared is 36 plus r squared is 8.3 squared is 68. 68.89. All right, now we're going to solve for r squared. Subtract 36 from both sides. And we're going to get r squared equals 68.89 minus 36 is going to be 32.89. Now we need to solve for r, so we're going to need to square root both sides. Now when you square root both sides, you do get a plus and minus solution. So the square root of r squared is just r. And this will give you a plus or minus solution. However, I always like to remind you of that. So I'm going to do the square root of 32.89 on my calculator and get a decimal solution. It's going to be plus or minus, and it is approximate. So I'm going to do a squiggly because I'm going to round to the nearest tenth. 5.73, I'm going to go 5.7. It's a plus or minus solution. However, since we're dealing with distance, we don't care about that minus solution. So we're just going to have positive 5.7. And that's our r. All right, the key to number 9 is knowing that when you have a point outside the circle and you have a tangent and you have another tangent from that same point to the same circle, that these will be congruent. So these two will be congruent, and from this point, these two will be congruent, and from this point, these two will be congruent. Knowing that is how you solve this problem. Triangle is circumscribed. The triangle circumscribes the circle. Find the perimeter of the triangle. So knowing that tangent rule, you have an external point and you have a tangent for the circle. And you know that because it circumscribes the circle. It's going to touch at a point. Okay, so each of these are going to be congruent. So if that's 10, this is 10. If that's 6, this is 6. If that's 5, this is 5. And then if you want the perimeter, you just add it up. So we have 15 plus 16 plus 11. And just add those numbers up and you're going to get 15, that's going to be 31, 41, 42. And there you go. All right, let's go on to the next one. Circle X is congruent to circle E. So these two circles are congruent. They tell us right away. What can you conclude from the diagram? Looking at these two circles, circle X is congruent to circle E. What can we conclude? Well, this is kind of an open-ended question. What do you want me to conclude? So specifically, what other parts are congruent? Well, look, these arcs are congruent. And you know if the arcs are congruent, you also know the chords are congruent for that intercepted arc. So I'm going to say WY is also congruent. WY is congruent to DF. Ooh, I am doing something weird here. Hold on. WY, that was weird. I zoomed us in by accident. Let's try that again. Okay, so I also know WY is congruent to DF. All right, and it's doing it again. I don't know why. Okay, let me pause and see. All right, I'm touching something that is making it zoom, so I'll try to be careful here. And then I also know, so I know WY is congruent to DF. I keep writing that, and I'm having a hard time with this part. It keeps zooming in. Okay, so I know those segments are congruent. I also know if this arc is congruent to this arc, this central angle is congruent to this central angle because the central angle is congruent to its arc. So I'm going to say angle WXY would also be congruent to angle DEF. And also because these circles are congruent, I don't know why it's doing that. Also because the circles are congruent, you know all the radii are congruent. So I know all the radii. So XY will be congruent to XW. So I'm just going to say also all radiuses are congruent. And let's see if I can get it to stop zooming in. So also all radii. I don't want to touch any of that. All radii are congruent. All right. Alrighty. let's see, on to number 11. So there, we have an interesting shape here. These are marked as congruent, so you know this is perpendicular. It's also marked perpendicular. Since this is marked perpendicular, you know these two segments are congruent. So this would also be 9. Now you know that since this is 18 and this is 18, these are congruent chords, and congruent chords are equally distant from the center of the circle. So if this is 8, this will also have to be 8. X is 8, and you're done. All right, so know your properties. Know your properties. Make sure you go over all those properties. A great place to go over your properties is at the end in the chapter review. It has a little snippet of each of the properties from each chapter. That's also a great place for the final review. All right, find the value of x. So here we need to find this value of x. X is a radius here. We have this segment. We see that it's perpendicular to this chord. So since this is perpendicular to this chord, we know these two segments are congruent. If this whole thing is 10, each segment is going to be 5. We're looking for the radius. What I can do here is I can draw another radius that will happen to give me a right triangle. That's how you want to work these. When you need a radius and it doesn't happen to be a hypotenuse, radiuses are congruent no matter where I draw them. From the center to this point gives me the hypotenuse of a right triangle. I know this segment. I know this segment. Now I can figure out this segment with Pythagorean theorem. I'm just going to go 4.2 squared. A squared plus b squared will be my hypotenuse squared, which will also be x. It's going to be the same value as this because it's a radius. So 4.2 squared plus 5 squared is going to equal x squared. And I just solved this. Let's go ahead and do 4.2 squared. And it's going to give me 17.64. 5 squared is 25. And that equals x squared. I'm going to add these guys together. 25 plus 17.64 is going to give me 42.64. And you know that equals x squared. And to find the solution, you square root both sides. When you square root both sides, once again, you show a plus or minus solution. I want you to be aware of that. We don't care about the minus solution because we're dealing with length. And I'm going to go ahead and square root 42.64. And we're going to have approximately 6.529. So we'll go 6.5 is the approximate value of x. And it didn't say round to the nearest tenth, but we're going to go ahead and do that. And there's your solution. All right, the radius of circle O is 28. So they tell us this radius is 28. We already know that. They say OC, this segment, is 10. You can see it's perpendicular because of the right angle markings. They want us to find AB, this whole section, this whole chord, I should say. We are going to round to the nearest tenth. So looking at this, once again, right triangles, lots of Pythagorean theorem on this one. So we're going to go ahead and find this segment. And once we find the segment, because we know this is perpendicular, it cuts the chord in half. We know these are congruent. This will be the same value, and we'll just double it. So we're going to go a squared plus b squared equals c squared. So we'll go x squared plus 10 squared equals 28 squared, which is our hypotenuse. And go ahead and do the math on this. X squared plus 100, and let's go ahead and do 28 squared. I don't know what that is off the top of my head. 784. To solve for x, subtract 100 from both sides. If I go too fast with this pen, it doesn't write. So it's nice and slow here. 684, and we're going to square root both sides to solve. You do the plus or minus solution. Once again, we don't care about the negative solution because we're dealing with length. I just like to emphasize that. So we're going to get x, and we're going to approximate this to the nearest tenth. It's 26.15, so we'll go 26.2. And so we found the value of x. Careful, we are rounding to the nearest tenth. That's not what they asked for. They asked for AB. So finish the problem. This also will be x. So the whole value will be 2 x's. So I'm going to find AB, which will just be 26.2, and we're going to multiply that by 2. And we get 52.4. Or if you didn't round this earlier, you would get 52.3, which is also, let's do an approximate, also fine. If you got, oh, I wrote 54. I'm sorry. 52.3 would also be fine. All right, on to the next one. Okay, I look at problems like number 14 where it says find the value of A, B, and C in this circle, kind of like a puzzle, using your properties that you know from this section. Okay, so you're putting the puzzle pieces together and trying to solve this. Angle A over here is an inscribed angle for this segment. So let me highlight this segment so we can see it here. All right, for this segment right here, you can see angle A is the inscribed angle for that segment. We know inscribed angles, not central angles. Central angles are equal to the arc. So you can see this angle is wider than this angle. Central angles are equal to the arc. Inscribed angles are half the measure of the arc. So A will equal 144 divided by 2. Once you figure out A, which is going to be, that is like scribbles there. A is going to be 72, all right? Now we can figure out, well, let's go ahead and erase that so that we can see. So we know A is 72. Let's write 72 there for A, all right? Now let's figure out B. You can see this arc is connected to this inscribed angle. It's intercepted arc for angle B. So if this is 48, this is going to be half of 48. So we're going to go ahead and figure out B, which is going to be 24. So we know B is 24. Figuring out the pieces of the puzzle. Now let's go ahead and figure out C. Well, we don't know its intercepted arc here. We do know this piece. If we knew this piece, we could subtract from 360 to figure out this piece, but you can see it's not an inscribed angle. Well, it is a vertical angle, and I know vertical angles are congruent. So here's our little piece of the puzzle. All right, so we have vertical angles. If I can figure out this angle, I know this angle. Well, I can, because I know this. I can figure out this because this is a triangle. So I'm going to go 180, and I'm going to subtract off 72 and 24. And I'm going to figure out what's left for that angle. So I just do this on my calculator. And I'm going to get 84 for that angle. If this is 84, this is 84. And then you've figured it out. So little puzzle and work through it. All right, let's go ahead and look at number 15 in the circle, find the value of x. Once again, it's kind of like a puzzle, using the properties you know. Do you know the properties that will help you solve this puzzle? So let's look. This is 31, that's x. This is 38. Is that helpful to me? Well, we know inscribed angles that intercept the same arc are congruent. So here is an inscribed angle. It intercepts this arc. So if this is 31, this arc is going to be 62. Well, look at x. It is also an inscribed angle that intersects the same arc. So it's going to be half of this, which is 31. So these will be congruent. This is also 31, and you're done. X is 31 degrees. So just know your properties, look at the puzzle. All right, more properties, same properties, similar properties. Let's go ahead and look at 16. It says if ACD, so let's do, oh, not B, sorry, ACD. So this is the angle we're looking at here. All right, so they said that angle is 46, right there. Then it asks for the measure of ABD. So we want the measure of, let me see if I can change colors here. ABD, this one right there. Well, here's this angle, it's 46. Look, both angles intercept the same arc. So I don't even have to double it to figure out the arc. Since they both intercept the same arc, this will also be 46, and you're finished. So what is the measure of ABD? It's 46 degrees. Okay, 17, find the value of A and B. Lines that appear to be tangent are tangent. So this appears to be tangent. It is tangent. Okay, which doesn't help us for knowing it's a right angle because right angles only happen from radii. the radii to the point of tangency would give us a right angle, but we don't have that. So the tangent is going to help us with this angle right here. So you have a chord and a tangent, which forces us an angle here. Let's go ahead and look. All the way around the circle is 360. We have 224 here. So B, the measure of arc B, it's just going to be 360 minus 224. So just go ahead and do the math on that. And you're going to get 136. All right, so B, this section here is going to be 136. Now if you look at A is going to be an inscribed angle with a chord and a tangent. So it appears to be tangent, it is tangent. This is also half the measure of its intercepted arc. So A, if I just do half of 136, I'm going to get 68. So A is going to be 68. So just knowing the properties, these problems aren't very hard if you just know the properties. That's it. Okay, find the value of x, and it says x is an angle. AB, this arc right here, is 27, and then CD is 23. So this is testing to see if you know the properties in section 8.6. This angle is going to be the sum of its intercepted arcs divided by 2. So this angle isn't an inscribed angle. It's not all the way over here where it would be half its intercepted arc. It's also not a central angle where it would be equal to its intercepted arc. It's somewhere in between. So what we do to find this angle, these are vertical angles, so they're going to be congruent. But to find either of these angles, we average the two arcs. This arc plus this arc divided by 2. 27 plus 23. And this is scribbles now, isn't it? Nah. Divide by 2. And we're going to get 25. So there's your x. All right, scroll down, come on. Okay, there's a circular cabinet in your dining room. Looking from another room at point A, so you're here in another room at point A, you estimate you can see the arc of the cabinet, so it's circular, of about 100 degrees. That's what you see, looking from the kitchen doorway to the cabinet, okay? What's the measure of angle A formed by the tangent to the cabinets? So this A, and you have two tangents. Both of these are tangents to the cabinet. What's the measure of that angle? Once again, testing to see if you know the properties. You can find this angle. It's not equal to the intercepted arc. What this angle would be is the large arc minus the small arc divided by 2. So you're going to find the difference of the two arcs, not the sum, the difference. So I don't know this arc. I know this arc. So what I want to do to figure out this arc, I'm just going to call this 360 minus the small arc, so minus 100. So this arc I know is going to be 260. Large arc and small arc. So I'm going to do 260, and you got to know your properties here. Large arc minus small arc, and then you're going to find the average of that. Divide that by 2. That's going to be your angle measure. And when you do the math on this, you're going to get 80. All right, number 20 is also a property, 80 degrees. A property from section 8.6. Knowing these properties, you have a tangent and you have a secant. So when your secant, when your secant and your tangent is your property instead of two secants, this would be different if there was two secants, okay? When you have a secant and a tangent, your property looks like this. I like to teach it like this. You have full times the outside, and if this was another secant, you would do full times the outside. However, it's not. It's full times the outside, and since it's not a full amount, you just do outside times outside. So the full amount, the full length here is going to be 9. So I'm going to do the full length 9 times the outside piece 4. And if it was another secant, I would do full times x, but it's not. So I just do outside times outside, x times x. x, which is x squared. All right, 9 times 4 is 36. And yeah, I swear this is the worst thing to write with. Square root both sides just makes me scribble. When you do square root both sides, you get a plus or minus solution. So you do get plus or minus 6. However, we are dealing with length, and we only care about the positive. That length would be 6. All right, scrolling down. All right, another property from 8.6 is this one. You've got two secants, and they intersect inside the circle, not outside. So in this case, you're just going to multiply this section times this section. So you're going to go 9 times, we don't have what I wanted. Hold on. All right, so we're just going to go 9 times 17, and that will equal 7 times x. And just do the math. 9 times 17, I don't have my 17s down, 153, and that equals 7x, and then you're just going to divide both sides by 7. Divide both sides by 7, and you're going to get an approximation because we have a decimal. So we're going to say x is approximately, and it's 21.85, so we'll do 21.9. 85 rounds up to 21.9. All right, going on to the next one. Let's erase that. And let's see if we can click that off. Nope. Determine whether the tangent, it's going to highlight now for me. I don't know why. Okay. Determine whether the tangent to the circle O is shown in the diagram. So how do we tell this? It says explain your reasoning. The figure's not drawn to scale. So we want to know if this line right here, AB, this line to circle O, is tangent. All right, to figure that out, what we want to know is if this line is tangent to circle O at the radius, I'm going to have a right angle. That's a property that I know. I'll have a right angle here. So if they tell us AB is 0.4, they give us OB, it's 0.3. They give us AO, it's 0.5. And they want us to explain a reasoning. Is this tangent, and why? Why is it tangent? All right, so let's go ahead and look. If it is tangent, it's going to meet at a right angle. So what I could do is I could use the converse of the Pythagorean theorem. If a squared plus b squared equals c squared, then I have a right triangle, and I would have a right angle there. If I have a right angle there, I would have a tangent at the point of tangency, where the radius hits the tangent. So I just need to prove that I have a right angle. So I'm going to go ahead and say if 0.4 squared plus, goodness gracious, that doesn't look like anything, plus 0.3 squared equals 0.5 squared, I have a right triangle. You can go ahead and do the math on that, and it is going to work. So this is true. And then what I would say is, and I'm not going to write it out because the writing on this is fuzzy, I would say this shows that I have a right angle and it is perpendicular at the point of tangency. So that's what you want to say here. Maybe I can type that. No, I can't. So this is true. So I have a right angle at point of tangency. Yeah, it's not going to write. Of tangency. All right, and that's how you do that one. So give me an explanation if you want full credit on a problem like this. All right, knowing the properties on this one, the following figure, the quadrilateral, is inscribed in the circle. Find the value of z and explain the properties you use to find z. All right, looking at this one, the one property that I would use, and I would explain this, if I have a quadrilateral inscribed in a circle, one of the properties tells me that the opposite angles are supplementary. So if this is 85, I can figure out this angle by going 180 minus 85. And I would write that out as one of the properties that I used. So I want you guys to write that out. I'm not going to write it out because my drawing tool is really hard to work with. So I would say that is 95. Now the reason I figured that out is because what I want is z. I could figure that out if I knew this part right here, this arc. Now, it's not the inscribed angle for this 95 degrees, but 95 degrees gives me this whole arc here. I do know this section is 64, so I can now figure out z. So if this is an inscribed angle, this arc is twice that. So I'm going to do 95 times 2, and I'm going to use 190 degrees. So I would say the inscribed angle is half the measure of its intercepted arc. That's the next property I used. So first property I used was in a quadrilateral opposite angles are supplementary when it's inscribed in a circle. Second property I used is an intercepted arc is twice the measure of its inscribed angle. And now I'm just going to use the subtraction property. I'm going to figure out z by going 190, and I'm going to subtract off 64. And that says 190 minus 64. In doing that, I should get 126 for z. And that should be the degrees for z. And there you have it. All right, let's move on to, did I do that one wrong? All right, the wheels on Reggie's bike each have a 20-inch diameter. His sister's mountain bike wheels have a 26-inch diameter. To the nearest inch, how much farther does Reggie's sister's bike travel in one revolution? All right, so let's look at this. We've got Reggie's, oh, I'm highlighting things again by accident. All right, so we've got, okay, there's my draw tool. We've got Reggie's bike that has a 20-inch diameter. And we have his sister's bike that has a 26-inch diameter. And we want to see how much further does Reggie's sister's bike travel in one revolution, all the way around. So basically we're looking at circumference. Circumference is pi times diameter. So we'll look at Reggie's circumference, and his circumference is going to be pi times 20. And we look at his sister's circumference, we'll look S for sister, is pi times 26. Now it asks us to find it to the nearest inch. So we're going to go ahead and multiply out pi and round this. So if I do 20 times pi, I'm going to get 62.8 approximately. And if I do 26 times pi, I'm going to get 81.7 approximately. So that's the circumference of the sisters. This is the circumference of Reggie's. So to find how much further does his sister's bike go, I'm just going to go 81.7 and subtract off 62.8. And when I do that, I'm going to get approximately 18.8, and it asks me to round to the nearest inch. So I'm going to round up to 19 inches. And there you have it. Not too hard. All right, let's go on to the last one. In the last one, we've got find the values of A, B, and C here. These three values in the circle. The figure's not drawn to scale. So once again, this is a puzzle using the properties that you've learned. So let's try to solve this puzzle. Looking here, I can see this angle is the inscribed angle for this arc. So A right away is going to be easy for me. It's twice this measure. If this is 39 and I double 39, I'm going to get A. So let's go ahead and do that one first. All right, so 39 times 39 is going to be not 39 times 39. 39 plus 39. I'm just going to double it. I'm going to get 78. All right, so this arc here is going to be 78. Now I need to figure out C and B. All right, so if this is 78 and I know, let's see what B would give me, what C would give me. C's intercepted arc would be here. I don't have anything on that yet. B's intercepted arc, if I go like this, well, look at that. B's intercepted arc is going to be easy to figure out because B intercepts the diameter. Do you see the diameter right here? because B intercepts the diameter, this value here is 180. This is going to be a right angle because half of that will be its intercepted arc, which would be 90. So now I figured out B. B is 90. Now I can figure out C because they gave me this was 50. So if this is 50 and the diameter right here gives me an arc of 180 because this is 90. When I intercept at the diameter, it's half the circle, so it's 180. If this is 180 and this is 50, I can figure out that little section right there, which is what will help me figure out C. Let's do it in purple. This little section here is going to be 180 minus 50, which is 130, that purple section. That purple section is the intercepted arc for C. So C is going to be half of 130, which is 65. And now I figured out all my pieces. That's supposed to be a 6. So A is 78, B is 90, C is 65. And there you have it. Let me know if you have any questions. Good luck on this test, and have a good day.